Well, anyways, while Amy is getting it ready, welcome. We're going to be talking about AI, of course, in the gray band 3 to 5. So I'm glad that you guys are here and you're joining us. We may get some other people along the way. There's usually shifting around at the last minute.
Okay, welcome to the third to fifth grade band, 3 to 5. This is to talk about how do machines learn from the data. And my name is Amy Iguchi. I'm a teaching professor at UCSD, and then I'm with two other amazing collaborators. Please introduce yourself. Scott?
All right. Hi, everyone. I'm Scott Moss. I am a instructional technology outreach coordinator at the Los Angeles County Office of Education, also a doctoral candidate in education at UCLA.
And hi, I'm Saul Duarte. I'm a tech coach with LAUSD. Good to see you guys today.
It's not coming up. Come on.
So you may need to share your sound.
You hear it?
Yeah.
Yes.
So anyways, while the sound is a little choppy, you guys can read the subtitles on the bottom. And the idea of showing you guys this video is because when we think of chatbots, right, we think they're very smart, they can do a lot of things. And here, what they did an experiment. They put in two chatbots to talk to each other, right? And when they start talking to each other, they begin to have this rather odd conversation, feedbacking themselves on each other's cueing. And you look at the subtitles, you'll see what I mean. It's very interesting, their conversation, right, of two chatbots talking to each other.
Yeah, let me stop it. Sorry. It's almost over.
Yeah, so and what is really happening is like they are cueing each other, right? As we heard from Emily at the beginning, a lot of the chat models, they usually try to predict what words come after. So one chatbot in this case listens to the other, and it takes that as a feedback, right, as data, and then it's gonna respond based on that, and then the other one responds back based on whatever the other one gave it, and so it's not really a full conversation, but it's more like you can see the still the lack of ability of some of these chatbots to be able to recognize language or natural language in this case, not being human language, but being just another chatbot talking to them. So that takes us to this conversation, right, of what is a chatbot. And I think there is nobody in the education field who has not come up with the word chat GTP in the last 4 or 5 months, right, since November. And we all kind of have been hearing about it. I've been reading a lot of articles on the newspaper. It's everywhere. It's on the news. And the idea is that we have this ability for a computer program that uses artificial intelligence to be able to conduct a conversation, right? To have a conversation with that almost seems natural. In the case of ChatGPT, it uses something which is called a large language model, which is another way of saying it can generate like language like a human would sound. It may have a dialogue, but that language is only coming because it takes samples of all the language that is out there, from books, from Wikipedia, from the internet, and is able to have a probability prediction of what the next word is. So it's what's called a likelihood of a distribution, right? If you think of a distribution curve, you will understand the probability that the computer can detect and says if you say one word, like Emily was saying, if, for example, a toddler says, "I am going, I go today, but tomorrow is going to be I go to, right, or I went tomorrow." So you can predict that word in a very predictable way. So ChatGPT does that, and the reason we call it ChatGPT is because GTP-3 is this big, large database, right? It's a large language model that takes a lot of language samples. And based on those language samples, they added the chat part. So it's a very good chat bot, right? With a very large amount of sources of data to inform it to what the next word is. And that's kind of what we want to work with you guys today. We want to show you guys a model and an example. And then later on, Scott and Amy are going to show you some more details about that. So having said that, you guys already know chatbots, right? Because if you have an Alexa or you have a Siri in your cell phone, or even when you type a word in Google, right? Or if you go to Google Chrome and you take a picture of something and you tell it to identify a bug or a plant or a flower, all of those are samples of some type of large database on the background, a model in which the program will take it and try to predict what is that you're looking for, what is the next thing that you want. And so we are kind of already used to the idea of a chatbot. We were not used to the idea of a chatbot that could actually sound very realistically, right? And that's kind of where we are right now in our very brief history of technology. So having said that, let's look at this example, right? This example is very simple, and if you can read that sentence, right? This is how machines know what the next word is. So for example, if I ask you, what color is the sky? And we're gonna complete the sentence, right? The color of the sky is, and to do that, there is a Mentimeter, and there was, I don't know, Amy, you want them to look at the QR code so that everybody can answer?
Sorry, yeah. Go. Let me go
before
back.
we show the. So there's
Yes.
a QR code, or there's a link there that you guys can click on it. Go to the Mentimeter and choose what would be the word that comes after the color of the sky is. So in this case, you are the chatbot, right? You are the algorithm trying to think what is the next word and what is the source of your data, right? Where is all this data that is coming from? It's coming from all your experiences in the past. That when you see the sky is going to be what color, right? And that is that prediction for us humans, we do it based on experience, data from experiences from a lifetime of experiences, right? But now ChatGPT is going to be doing the same thing, only it's doing it based on quantitative data through probability. So let's see if we have any data here. Do we have any data, Amy? So, but I figure you guys understand that the word we're looking for is the word blue, right? I mean, yeah, there might be the case that the sky might be orange in the evening, or it might be brown or dark when it's raining. But for the most part, the answer would be blue. So if it would be ChatGPT, we would probably have a probability guess that the word that we're looking for is blue. And that's kind of what ChatGPT does, only it does it like super fast with millions and trillions of words, right? All happening very quickly in the background. And that's what we want to show you, how this process works and what does it look like. And do we have data? I want to see the data, because the data is really what drives the prediction, right? If we have data, then we can drive the prediction that the word that we're looking for is the word blue. And this
I can't get it work.
don't worry about it,
Sorry.
Amy. I think we understand the prediction part and what is the processes which we're looking for, experiences that guide our ability to predict what is going to be the outcome, right? And in between, we have this process which in our mind is our brain working like in the way of an algorithm. So having said that, I want to let Scott take us to the next level, right? Because this is just a very simplistic way of thinking about it. But now Scott is going to take us a little farther down the rabbit hole here. Scott, all yours.
Alrighty. So as Saul was saying, he's talking about something called a large language model. And when we're talking large, we're talking really large. As our keynote speaker said, basically, it reads the entire internet. It reads everything, and not just a collection of words, but collections of sentences. So like that example that we just saw of what is, the next word, that's really how large language models work. So, the sky is blue. If you say candies are, well, most people will probably say sweet, but there could be some other ones. But so basically, the way these large language models work is they will put in the word that occurs most often, but there's also an aspect to it that's trial and error. But the thing that's hard for us to comprehend with our human brains is the size of the data set and the speed at which these computers can process this data. So basically, it's just it's a kind of a prediction engine. So if you say LeBron James is a good basketball, what word possibly could come next? So there's only just a limited number of words that could come, and that's basically the way it works. And if you've used ChatGPT or these other, or Bard, or any of these other generative AIs, it's pretty remarkable how that kind of model can create the kind of results that we're seeing. But that is how it works, is just by guessing the next logical word in the sequence there. So the next slide here. So basically, there's this kind of 3-step model, and this applies to all algorithms, whether it's AI or kind of a more kind of general idea of algorithms. I don't know if that's cut off or it's just not loading on mine to see half, but it's the other goes. Maybe mine's being slow. So there's the data or the input, and there's the algorithm. That tends to be the kind of the invisible part, except for today it won't be. And then the prediction or the output. So I've done this thing with younger kids where, and we can share this later if you contact me, where you compare it to making a cake. So the ingredients of the cake are the data, the learning algorithm is the steps you use to put the cake together, and then then the output is the finished cake. Okay, and that's a really easy way to think about it, because algorithms in the most general sense are just a way of solving problems, right? So we are going to actually think about the data set. So the data that is used in an AI is very important. And the quality, there's this old saying in the computer science world, garbage in, garbage out. So if you have bad inputs or bad data, then what's going to come out of that is going to be bad. Or if it's incomplete, if you're trying to make a prediction on, okay, well, what's the best movie? Recommend a movie for me out of, but if it's only got, 10 movies in the data set, then you're not going to, then there's missing data. It's going to give you a more limited output. So the quality of the data that goes in really affects what goes out. And as it says here, the data within ChatGPT is a large language model, which basically scoured the entire internet since 21 or 2019. It's not quite up to date, but it's pretty close. So there's a lot there. Okay, so Amy has designed this great activity to help us see that kind of middle step of what we're doing. And am I sharing my screen now, or no? You can just kind of. Are you going to do this, or you want me to, Amy? Or so. Hopefully you're all familiar with the program named called Scratch, a free block-based coding tool. It's extremely popular. It's been around for about 15 years or more now, and there's tons of resources for it, and it's good for all ages. And one of the great things there are many great things about Scratch. I love Scratch, but one of the great things about it is that you can remix it, meaning you can take an existing program and then you can change it without altering the original, right? So that's great for a lot of reasons, because then you're not starting with this blank page, like, I don't know what to do. You're also seeing how the original works. Do you agree with this statement? Yes or no? Do wizards exist? I'm going to say no. So it says, do you agree with this statement? Yes or no? I'm going to say no. The frog says they do not exist, but and I'm going to say yes, they do. It still says no. I'm going to go here. Aha, look at that. Now that we've got 6 votes, we've outvoted the no's. So this kind of is an example of how ChatGPT works. Basically, it's kind of like voting. It's going to pick what's most likely to be next here. So one thing I'm going to do, and I don't know, I think you're going to show this next part, but just so when if you don't know this already, if you're in a Scratch program, any Scratch program that you can find, there's this great button here that says, well, there's 2 things. There's See Inside, So you can see the code, right? And there's also this remix. Now, to do remix, you have to have a free Scratch account, but that allows you to, so if I'll just do it just to show you, I can click remix and basically it's like a save as. So now I can go here and I can change some of the things inside these code blocks, and then it's not gonna mess up Amy's project at all. Amy, it still retains it, and it actually automatically will give credit to the original author, which is great. So what Amy is, I think Amy's going to walk you through this. What she's done is within the code, she's added these comments, and you can click on these and you can get more information about what they're about or what there are ways you can remix it. So I'm going to stop sharing and I'm going to send it to Amy.
So what we actually wanted to do is for the kids to try out and then ask some questions. Because we model what kids want. We want the kids to do, students to do, and then have them observe what happened and then share with the partner and then share with the class. Basically, Scott sort of walk you through, but the student can say, oh, so the more number it has, the sentence, the word, the machine picks is the word was more bold. And another question that we want to ask is, what if we all cheat and lie? What's going to happen to the result? So to sort of trigger students to think about misinformation, using the misinformation on the website or the whatever the data it's using could affect the result. So what the Scratch game was doing is the question generated the data. So using the data set and using the code in between to have the machine or the sprite predict the answer. So that's basically what the game is doing. And the next is, let's say, kids can expand it. Oh, I skipped 2. Oh no. Yeah, so this kind of walks you through how the code is made. And I don't know if the 3rd and 4th and 5th graders, maybe 5th graders use variables. I'm not sure. I think it's really depending on the teacher. But we want to tell the kids we're using something called variables. And then we have the no variable, total vote variable, the yes variable. And the variable is basically like a container that receives a information, or I usually say like input. Then keep that in that container, that's a number, and they use that data for this activity for its prediction. And on at the top of the code, it actually set the variable to 0, so that it always start from 0, so there's nothing in it. And next step is each yes and no buttons are sprite. You probably know tip and see. And the C, then first you need to check the sprite, and then checking the sprite, and then sprite has this code under sprite. Each sprite has, so yes and no has this, and then every time somebody clicks, and then that adds the number to the button itself, and then total votes. So that goes into the container. That becomes the data for the Scratch to use. And the same thing. So that was no. This one is yes. And then once you have those numbers into the variables, and we are basically comparing the variables and see which one is larger. So that if statement is where the machine decide what word to use. Never cared about variables. Coordinate plane. What level got?
You're asking me about my statement that
Yeah. I have students say that they never cared about variables and the coordinate planes.
meaning that so they learn about variables. I wrote, for those of you who can't see the chat, I've had students say that they never cared about variables or the coordinate plane until they needed to apply them in a meaningful context for them, which was making a program work. So in the past, they've done it for math teachers and just done it, to do schoolwork. But then when you need to apply variables to keep score in your game or to make your sprite move, then it's got more meaning to them.
Okay, so this is hopefully help the kids to really understand what it means.
Yes.
Right. So the back end, not the back end. Once you open inside, this is the whole sequence is the code itself that Scott was showing, and then you can see that red box is where each section is used. So that's where the data is set for 0 and then collected behind the scene, but then using the variables to compare which one has a bigger number, depending on how much more, not how much more, bigger or smaller, and then it defines the statement. So, and I have, sorry, I'm gonna skip. I did this. I think it's kind of the reverse order, but I have a simpler version of the code itself. So it's much shorter because sometimes kids get intimidated by looking at a long code. So this one is slightly shorter because it doesn't change the sprite when it's responding. So if your student, you think your students like the simpler version to start with, then this is the one that you can use. So I just wanted to show. If it's in class, I don't know how much time that you have in class. From here, it's more like a student's independent study, independent work. So we want students to open the Scratch and then remix, and then see if they can do some modification or change it to the game that they want to play with their friends.
So, at this point, what we're trying to show you is, the idea that when we have something like a ChatGPT or artificial intelligence, it requires to have data, right? And the data usually comes from us. And that data, represents the way that we do things and the way we represent that information. So the program that Amy and Scott were trying to show you is a way to also use it with the kids to be able to see how when you input data into a program, you're going to have the data, the input on one side, and you're going to get a prediction on the other side, right? Like the in and out of the machine. But what happens in the middle, that hidden layer, really depends on the program that is created and the kind of questions that you're going to have. And that's a really great representation of how artificial intelligence is actually put together as we're speaking right now, regardless of how large the learning model is or how much power the computers that are powering these chatbots are. The process is very much the same, right? We want to be able to focus on that thing in the middle, on that process that we want to be able to understand and be able to explain to our students. So this is more a moment for you as well, to participate. When we look at these questions, is how do machines learn? What do they need? What happens when the data the machine uses is not correct? And I want to just open it to you guys. What do you guys think? How do we answer these questions? And I would love to hear your thoughts. What do you guys think? How do machines learn?
Yeah, you can type in the chat or you can speak up. I mean, anyways.
Yeah, you're welcome to unmute yourself too, because we don't want to do all the talking. We want to be able to also have this conversation, right? To say, look, this is how it works, but also, what are your thoughts? How do you see this happening?
I think if it's using erroneous data, it could come into the results that it spits out, right? Because it's just taking what it reads. For instance, ChatGPT, since it's read the whole internet, some of that stuff that it reads is false. So at times you could search for things, and a false answer could come out, because it's come across that, even though the probability of the correct answer is more probable to come out. For instance, you could potentially type in 2 + 2 is supposed to equal 4, but it could potentially say 2 + 2 = 5 because it's read that somewhere within the internet, as one of its pathways. So it's just it's a crapshoot, I guess, out there. There's still a level of discerning you have to do as the user, for sure.
Absolutely, and that's a really interesting thought, because that's actually one of the things that they're trying to do with this data sets, right? They're trying to curate them and to try to avoid those things. Because even Scott was just telling me a couple of days ago. Remember, Scott, you were telling me about that experiment they run when they were some of the first chatbots that they began to make, and they began to have them read social media, right? And in a day or two, that thing became like really antagonistic and really nasty, because he was reading all the nasty stuff on the social media, right? And so now I think the trick is what kind of data do we put in it, and how do we curate that data, and how do we synthesize that data? And there's a lot of companies out there precisely doing that, and they're beginning to call it that, synthesized databases. So to prevent that kind of problem, but it's still there, right? It's part of the problem. And Scott, you're right? This
I really appreciate the, opportunity to pause and process a little bit of this. I do know I've been investigating this whole thing about large language models and language learning models ever since I was even hearing about ChatGPT, which obviously is just maybe a month ago or so. But in that time, trying to understand more about how this informs us about the ways in which machines learn and how they use what they learn in ways that can automate processes or help you get these responses. I guess what I was trying to process right now is working with grade 3 through 5 teachers and thinking about how might we work with our young learners to intuit several layers of this. And to me, it seems like it intersects both digital literacy concepts as well as computer science concepts as it relates to thinking about the validity of what you're seeing online, and that it's all coming from these large data sets like Rod, a reference could be false. So therefore thinking about how might they be really discerning readers and engagers with the technology, but then thinking about how might a lesson like this be used in a way to help them see. Like, for example, in the example you gave, Dr. Iguchi, with the Menti, I deliberately put in like dark and like cloudy. I do know that blue is the thing, but I think it's interesting to see how that's all utilized in like those sets. So that's what I'm thinking about right now.
I think a key part of that is kind of doing what part of what we set up today, which is having kids interact with the algorithms. You talked about digital literacy, or I think of maybe more broadly media literacy. So if you want kids to learn about movies and TV, you might teach them about camera angles and music. And now the bad guy is coming because the lighting and the music. Give them that kind of behind the scenes. So things like activities like this in Scratch, or things like Google Quick Draw or Google Teachable Machine, where the kids are getting that kind of firsthand experience with input processing and output, and seeing how if they put in, like you said, intentionally wrong input, and how that's going to affect the output, and they can really kind of connect to it. I think part of the challenge for younger kids, I'm doing my case study on this as we speak, is finding some of those examples. So of bias and their impacts in the world, if you're interested in teaching that. Because a lot of those impacts, things about think about credit worthiness or policing, they tend to be not really connected to the experience of third, fourth, fifth graders. But I was thinking of I saw this example recently of I guess they call it racist soap dispenser machines. The automatic soap dispensers don't work for darker skinned people and those kinds of things. So there are examples out there kind of seeing how those impacts, how the algorithmic bias has impacts in the real world, which is something I'm interested in.
Yeah, thank you for all those thoughts and shared examples. One of the things that I was thinking of is like, so the majority decides the rule basically exists in the human society, right? So whoever have a better representation in the society gets to choose or get to decide. And then that's actually happening with the AI machine learning too, because the kind of data. So who's collecting, who's making the data, who's feeding the data? Is it correct or not? Does that impact everybody, or does it just benefit small number of people? And so to make that connection between what's going on in inside of the machine and what's going on in the society is really important, I think, for even younger kids to think about. So so the Mentimeter example is like, so you can like just have kids fill out first and then talk about it. And then what if we all pick something that's not correct for the sky or the candy? Everybody can say candy is bitter. And what's going to happen to the machine to think, like, because it doesn't taste anything? So machine's going to say, oh, because so many text says candies are bitter, then the machine's going to spit candies are bitter. But reality is it's not. So all those like playing with the scratch and then also think about the actual real world is something that I was thinking of when I was creating this activity. So you all get, touched upon all the spots that I was actually thinking of. So thank you.
But I also, I'm always not. I'm thinking of AI as also as something that is going to be changing always towards the positive. And I can give you an example. Google created this thing called BERT, which was an early version of a chatbot, right? And BERT, for example, couldn't tell male from female words, right? And it was labeling things that were female, male, and you would say, well, that how is that possible, right? And when you start really realizing who's doing all this coding, it's usually males, right? And so the word the female part was not present in that code. Was that fixable? Of course. When they realized that that was happening, they went back and they fixed the code and they put filters and all. And now BERT works, right? And BERT is behind a lot of the customer service machines that we hear that when you pick up the phone, that's probably BERT talking to you, And so BERT got fixed and he moved on, right? And so that's what's at the point that we are with chatbots is that, yeah, there might be some deficiency that the danger always of bias is going to come in, right? Be gender, with class, with race. Those are really real issues. And at the same time, by us being aware of it and having our students play part of that conversation, we can be the catalyst that make those things be fixed so that they don't do that, right? And so in a sense, we're kind of like an innocent age, right? When these chatbots don't know what they're talking about, right? Like Tay, for example, in Microsoft Tay didn't know what it was talking about, but he was saying some nasty things, and that's what, but the real reason behind all this is that we need to know how the machines learn, right? And how do they do it? And what happens if the data is wrong? Because when the data is wrong, it's real, right? It's real effect on real people and real humans. And the way BERT got fixed, then other new ones are going to get fixed. And I think that's part of the hope, right? The word of ethics that we want to be able to embed into the development of artificial intelligence. That ethics, the ability of us to know what's good and what's bad, has to be embedded into the system as well, not just because we know that the tendency for us human beings is not good ones, right? I mean, we human beings, we tend to create these systems, right, that have to reproduce what we are, and these are what we are is not that good. So we gotta make them better than we are. But having said that, I always see it with a positive note that there's always a way for the machines to learn in a way that is better positive. And I hope that as you know, in the future, as some of these chatbots begin to be developing a different way, and they're already talking about ChatGPT 5, right? And now I suggest you guys to try Bard, too, which is the big brother, the other one, you know, the one from Google. Bard, you can go on site, put yourself in the wish list, and 2 days later they'll add you. You can try Bard, and believe me, Bard is better than ChatGPT. And you will say, "Wow, why could it be better than ChatGPT?" Well, Bard could be better, right? And what the next one that is coming after that, right? So there is a lot of positive notes that are going to help us. Technologies that have a lot of potential and a lot of power, but it really depends how we make them, right? How we train them. And so having this conversation with our kids, I think is amazing. Uh, we want to suggest you guys always to look at our website, the AI for California website. There's a lot of great resources there, lesson plans already made, slide decks that you can use that are very appropriate for your grade levels, be high schools or be K-2. You can always do that. There's also other sources, you know, like AI for All or OpenAI, which is coming up. So there's a lot of good places that you can take and begin to have those conversations. And it doesn't have to be coding, right? It could be an unplugged activity. It could be simply a conversation of what AI is and how we can participate in this conversation. And yeah, and Amy's putting some of the resources that are online. And but having said that, I don't want to end up the conversation. I want you guys to some of you haven't talked to us yet, like Elizabeth. What do you think, Elizabeth? I see you. I know that you're with us, and Elaine, and Allison. What do you guys think? And I know, Allison, you put a nice comment, right, on the chat about machine learn based on the information that is presented or fed to them, and that's true. In because yeah, and the idea is right that how do we engage our students and our educators, and I think that to a big extent now, the students will be very receptive because they hear about ChatGPT, they know about our AI, and they want to know, right? They're curious. A lot of
What
these conversations.
the common like apps for AI?
I'm sorry, could you say that again?
What are the common apps for Chat GPT AI?
Apps like that you can use. Well, there's different ways of seeing artificial intelligence. Sometimes we think of chat as something that you can interact with, but there's other types of AI, like, for example, that generate new images for you. There are some that generate music for you. There are other ones that generate information from you. So it depends what you want to, any kind of realm that is on the internet, either information, creation, it's out there already. I mean, there's companies that are making things that if you tell them, make me a slide deck about insects, these things put it together for you. I mean, they literally will. You just have to feed it, right? And the trick is the prompt, the chat, right? How do you tell it? How do you ask the chat? You have to be very explicit and very complete what it is that you really want. And then the better and more precise you are, the better results you'll get.
I tried like the image generator by giving the description, and it always come out really distorted and scary looking.
Yeah, but there are many. There are Adobe is coming up with one called Firefly, which is really nice. Okay, and there's other ones like what is called Deep Generator, and DALL-E, and there's a lot of resources now in the website, and explore, have fun with it, and learn, because the more you know, the more you learn, then you can take that to your students as well, right? And begin to have that conversation with them. Because believe me, if you have those questions, they have those questions too. And I have had these little first graders, you start talking to them about AI and they're like, oh yeah, I think I heard about it. And and you think they're not listening. They are listening, right? They are curious and they want to know, and certainly high schoolers as well.
Rod had his hand up. Rod, did you want to?
Oh yeah, just in response to like what apps make it more accessible. I know that within like smartphones, or a lot of like middle schoolers or whoever has a smartphone and uses the Snapchat app, they have incorporated ChatGPT 3.5 into a interactive bot, where it's just called My AI, and it's an easy way to access ChatGPT 3 outside of the website interfaces that we're all referencing here. I know my nephews use it profusely within their schools and classrooms. And I encourage them to continue to use it because it's actually making them more engaged, like in class, which seems counterintuitive, but they tend to be fact checking their teachers or things like that, or feel ready to respond to certain things that teachers asks. Whereas it's not much different than looking it up on Google. It's just a lot faster.
Thank you, Rod.
Yeah,
That's
but
a great comment. And
yeah,
you
but
know,
also the skin on the app, like TikTok has very different variety of skin that you can use. That's AI. It's not ChatGPT, but it's super scary though, because as if you don't exist and you become totally different person even.
so
Yeah.
having said that, you know, I put a link on the chat, which is our survey, our exit survey for today's AI preparation for the next week. So we ask you to please fill it up if you can. But great comments, you know, and you know, Allison, you are totally right. It's overwhelming, right? When we all have been thrown into this new world of artificial intelligence, believe me, we all are in this. We're figuring it out as we go, and learning is the first step, right? So we suggest you guys to continue learning, keep visiting our website, keep inquiring, and the more you know, the better you are. And when you feel comfortable, you can have that conversation with your students as well. And thank you for being here. You know, I'm Saul Duarte. I'm very appreciated that you guys are here. We had this conversation also with my partners here. Amy, Scott, you want to say goodbye? And
Yeah, thank you so much for coming. Yes. And then please fill out the form, but also I think it's really important to talk about it than ignore as if nothing is happening, because this is happening. And it's important for kids to really understand what it is, what kind of impact that those AI tools has on their lives, and then what's important for them to be able to contribute in the future. And then could be programmer, or could be a smart users, could be a creative generator of AI in the future. So all those are important. So thank you.